In this video, I want to introduce you to the idea of a repeated game. In a repeated game, you play the same game repeatedly, as the name suggests, several times. In a one-shot game, there are no consequences outside of the single interaction between the two players. Specifically, there's no relationship or reputation that the players build. But when you repeat your interaction, so when you interact with the same opponent over and over again, there are scope for things like relationships and reputations. And we'll see that in our analysis of repeated games. So let me just tell you the basic setup here for what a repeated game is. There are t periods for t capital T. T is either some finite number, or it could be infinite. So when capital T, the total number of periods is infinite, then this is an infinitely repeated game where the players play the same game every period in perpetuity. In every period, they're going to play the same game, and that game that they're going to play in every period is what we call a stage game. You might wonder why we call it the stage game. It's because game theorists often use the word stage interchangeably with period. So in a given stage, that's the game that you're going to play. For our purposes, we're going to make the stage game just be a very simple simultaneous move game. We're going to represent by AI the actions available to player I in the stage game. So a profile of stage game actions is in the set capital A, which is just the product of the n different players' stage game actions. There's going to be a utility function that tells us the payoff in the stage game for a player I. So UI is player I's stage game payoff function. So UI of A, where A is some profile of actions, is the payoff that player I gets in the stage game when the actions played in the stage game are A. In other words, when each player J has played action little a J. And then this is the payoff in that stage that player I is going to get. So we'll represent by just U without a subscript the profile of utility functions, UI for each I. So the set A and U together define a stage game. This is very much like a simultaneous move game or a normal form game where player 1 has a strategy set A1 and the utility of player 1 is given by U1, and so forth. So in each period, they're going to play the same game over and over again, capital T times. And that could be infinitely many times. There's going to be an important new concept here. So in each period T, every player sees the history of action profiles played in all the periods leading up to T. So A1 were perhaps the action profile played in period 1, A2 is the action profile played in period 2, all the way through AT-1. So those are all the action profiles that have been played. Those all together form a history. And the history up to period T consists of the action profiles chosen by the players in all the periods up to period T-1. What is the payoff of the player? Each player's payoff is the sum of the stage game payoffs. And we're going to discount that. So player I's payoff is the sum from little t equals 1 to capital T of the utility that player I gets from the action profile that the players choose in period T, but we're going to multiply that by a discount factor, T-1. The first period payoff is not discounted because it's delta I to the T equals 1 minus 1, which is 0, so it's 1. And the second period payoff is multiplied by delta. The third period payoff is multiplied by delta squared, and so forth. So we are going to discount future payoff. In particular, whenever capital T is infinity, we're going to need delta I to be less than 1, otherwise this sum might be infinity. We don't want infinite payoffs because then we might be comparing two infinite payoffs, which isn't a useful thing to do. So typically we're going to assume that delta I is less than 1 when T is infinite, and when T is finite, we'll typically assume that players are patient enough that delta is 1, but sometimes we might assume that it's also less than 1. So this is the general setup for repeated games, and we'll see both finite and infinite repeated games in the next videos. In particular, for the finite games, we'll stick to the simplest example, which is just 2-period repeated games, and we can see all the lessons we need to see from just the 2-period game.